Now we're going to specifically talk about those vertical asymptotes on my rational functions. Here I have a graph drawn. You can see that this is some sort of rational function here, and I have vertical asymptotes occurring at -3 and at +3. Okay, and the asymptote is actually defined by the equation x equals some number. Okay, so and it's always x equals because vertical lines are, that's the equation for a vertical line. Now, when we are going to talk about vertical asymptotes, we want to do two things. First, we're going to reduce the function, and then once we reduce it, we're going to see where the denominator is equal to 0. This is different from finding the domain, because in this case, for finding the vertical asymptote, I'm going to reduce my function and then find the denominator, where the denominator is equal to 0. So let's jump in, and I have 4 examples that we're going to work in this video. The first one is this one right here. F of x is equal to x plus 3 divided by x minus 1. Now, if I'm being asked to reduce my function, that would entail me factoring both the numerator and the denominator. This rational function is already as factored as it can be, so I cannot reduce it any further. Now, one thing I like to point out to my students is if you thought by some reason that you could cancel this x in the denominator with that x in the numerator, you're not alone in making that mistake. Okay, you cannot cancel these two x's because they actually have an addition or a subtraction sign contained with them. In other words, they are not factors. I can only cancel factors when I reduce fractions. So this is as reduced as it's going to get. We're going to take the denominator, set it equal to 0, and find out that I have a vertical asymptote at x is equal to 1. This is my vertical asymptote, VA. And that's pretty much it. All right, let's move on to this next problem. This says I have a function x divided by x squared minus 4. Again, I cannot cancel those x's because they are not factors because of this subtraction sign here. It doesn't do me any good to factor the denominator because I don't have anything I could cancel it with in the numerator. So we're going to go ahead and just take the denominator since the function is already reduced, set the denominator equal to 0, and solve. So I have x squared minus 4 equals 0. I'm going to add 4 to the right-hand side. I get x squared equals 4. Let's take the square root of both sides, and I'm going to find out that x is equal to, the square root of 4 is a plus or a minus 2. This tells me that I have vertical asymptotes when x is equal to positive 2 and when x is equal to negative 2, similar to this graph that you see right here. Positive and negative 3. Okay, so these were the vertical asymptotes for that function. How about another example? We're going to try to make these a little bit more difficult. So here I have x squared over x squared plus 1. Again, don't fall for this. You cannot cancel these two x squareds because of this plus 1 here. So let's take x squared plus 1, set it equal to 0, and solve for x. So I'm going to subtract 1 to the right-hand side, and I get negative 1. But if you stop and notice, I cannot take the square root of negative 1. So what this says is that there are no vertical asymptotes. And that's okay. That can occur. We don't have to have vertical asymptotes for every single rational function we encounter. So that's an option. Okay, finally we have this example right here. X squared minus 9 divided by x squared plus 4x minus 21. This is the time where we get to maybe factor the numerator and the denominator to see if I can cancel anything out. So the numerator is going to factor into x plus 3, x minus 3. The denominator is going to factor into, let's see, I have x and an x. This negative sign tells me I have to have a plus and a minus. So I'm looking for the factors of 21 that are going to subtract to give me 4. And that would be a positive 7 and a negative 3. because -3 plus 7 gives me -4. So all I've done is rewrite my rational function here on this side in its factored form. Now that I have factors, I can see, are there any common factors that are going to cancel? And sure enough, this x minus 3 in the numerator and the one that's in the denominator are my terms that are actually going to cancel. Now that I have this portion right here, x plus 3 over x minus 7, it's the x minus 7. It's this factor that is left in the denominator that I'm going to set equal to 0 and solve. So I find out that there is a vertical asymptote when x is equal to -7. This is the vertical asymptote. Now you might be asking yourself, well, what happened to this -3 that we had right here that we canceled off? And although it's not a vertical asymptote, it actually ends up being a hole in my graph. And we'll talk more about that in a later video.